Um, After we have learned about the corrosion mechanism and the corrosion types and how the corrosion takes place and why the corrosion happens for metals, uh, we review again the forms of corrosion. We learned that there is stress corrosion, erosion corrosion, pitting corrosion, ceramic corrosion, galvanic corrosion, intergranular corrosion, selective leaching, and uniform attack, and other types of corrosion. Now we must come to the point of how we can protect our devices and equipments from corrosion. How we can eliminate and stop the corrosion. Is it possible? Yes, this is possible by following the uh, techniques of corrosion control. So in general, there are several methods to control the corrosion. We will focus on four methods on corrosion control. Firstly, corrosion can be controlled by selection the proper material which is less corrosive than the others. Secondly, we can protect our metals from corrosion by coating. Third, measures are to control the environment to prevent the conditions which lead to this reaction. And finally, the reaction, we can also manipulate the reaction process of corrosion, and we can protect our metals by some techniques related to reaction mechanism. Corrosion control by material selection. So either we can select metals or non-metals material that depends on our application. For example, we can use copper metal for particular environment. For reduction conditions, we use nickel and copper alloys. If the condition is oxidizing, we use chromium based alloys. Secondly, if the materials non-metallic, limit use of polymers in presence of strong inorganic acids. We can use ceramics also, but corrosion resistance, but the corrosion for better corrosion resistance, but ceramics has disadvantage because it is brittle and sometimes it doesn't meet our functional requirements. So if since we use the iron or ferrous alloys metals which is subjected to corrosion, then we go to other methods of protection of our equipment from corrosion, like coating. The coating could be metallic coating. We use it to protect metals by separating the metal surface from corrosive environment and serving as anodes. Sometimes the metallic coatings, that means the coating or the paint, involve metals, or we can coat by electroplating. We coat some metals. These metals plays a major role to protect our iron from corrosion. For example, we can use some iron oxide containing metals. We can use zinc metal as a coating element. Might have several layers also. Inorganic coating, we can coat the ceramic by we can coat steel by ceramic, or steel coated with porcelain and linen and lined with glass to protect it and to isolate it from the environment which causes corrosion. Organic coatings also, like organic polymer, it is very famous, or it is very common in our life, in our technology, and it is less expensive. Paints and varnishes are used for coating, serve as barrier, but should be applied carefully, because any defects in the coating can be a seed for corrosion, or pitting corrosion, or other types of corrosion can take place in the defects of coating. So design, the second measure is to design to make proper design for our equipment to avoid the corrosion. In general design rules, we have some rules to make our design more or less subjected to corrosion conditions. Like we provide allowance for corrosion in thickness. So when we design vessels, tanks, and according to our functional requirements, that means our pressure and stress needs, for example, certain thickness, and then we add more thickness for two things, for two purposes. One is for the safety factor, and the other one for corrosion allowance. We try to use welding rather than rivets, and we avoid crevices for corrosion. Avoid dissimilar metals that can cause galvanic cell. Avoid excessive stress, and stress concentration. Avoid sharp bends and in pipes to prevent corrosion. Design tanks and containers for early drainage. Design so that parts can be easily replaced, because if the corrosion had happened. Design heating system so that hot spots doesn't take place or doesn't occur. The third measure for corrosion control is alteration of environment. For example, lower the temperature, reduce the reaction rate. Decrease velocity of fluids, reduce the erosion corrosion. Remove oxygen from liquids, reduce corrosion. Reducing ions concentration decreases corrosion. Adding inhibitors are retarding catalyst, and hence reduces the corrosion. Finally, we control the corrosion by interfering in the reaction itself. For example, here we try to provide cell protection for metal. Metal ions combines with oxygen to form thin adhering oxygen layer that slows the corrosion. For example, some metals, for example aluminum and some stainless steel, some kinds of stainless steel, forms a metal oxide. So initially it will react with oxygen and it will make a thin layer of oxide, which can play a role as protective layer against the environment to make the bulk of metal isolated from the environment so that the corrosion doesn't happen. And when we reduce the temperature, the slows any reaction. Most of the reactions, the rate of reaction increases with the temperature because of the kinetic of the reaction will increase. The activation energy will be more suitable for the reaction by increasing the temperature, so that the lower temperature it's better for reaction, for inhibiting the corrosion. Adding the inhibitors slow the oxidation reaction reduction by removing reactants. So sometimes the inhibitors reacts with oxygen gas to faster than the metal ions, then prevents the process from completion. Slow the oxidation reaction by attaching species to the surface. And finally, the cathodic protection. The cathode protection, we connect our metal that we want to protect, like stainless steel here. We make like electrical connection or between our metal with a sacrificing metal. This sacrificed metal must be in the bottom of the oxidation potential ranking table. So for example here, the zinc will be available in the neighborhood of stainless steel, and we make electrical connectivity between them. If the environment is suitable for corrosion, the zinc will be corroded to provide stainless steel with electrons. These electrons prevents the iron from being released in the solution or in the drop of humidity, but the zinc will be consumed. By consuming the zinc, stainless steel will be saved. And this kind of configuration also can be used here nearby the pipelines. We put a node like magnesium or zinc, and we make a copper, this copper wire for connection. The magnesium will work as a node, and the pipe, the steel pipe will be cathode that prevents the corrosion of stainless steel, while the anode will be. Anyway, the cathodic protection is providing our metal with electron source to prevent it from dissociation from the bulk of the metal. So the summary of corrosion. Corrosion occurs due to the natural tendency of metals to give up electrons. Electrons are given up by the oxidation reaction. These electrons then used in a reduction reaction in the other side. Metals with a more negative standard electrode potential are more likely to be corroded relative to in comparison with the other metals. The galvanic series ranks the activity of metals in seawater. Increasing temperature speeds up oxidation reduction reaction. Corrosion may be controlled by using metal which form a protective oxide layer or by reducing the temperature, or by adding inhibitor, or by coating, painting, or by using